Hello student, welcome to my channel. Today we solve some problem on fiction under engineering mechanics, chapter name fiction. Problem number 3. Problem number 3. Find the force required to move a load of 30 Newton up a plane. The force being applied parallel to the plane. The inclination of the plane is such that a force of 6 Newton inclined at 30 degree to a similar smooth inclined plane would keep the same load in equilibrium. The coefficient of friction for the rough plane is 0.3. Load of the body is 30 Newton. Rough inclined plane, inclination not given. Force apply parallel to the rough inclined plane. Here inclination of the plane is the same when inclination of the plane is such that a force of 6 Newton inclined at 30 degree to a similar smooth inclined plane. Okay, keep the same load in equilibrium. First, we find out smooth inclined plane. Here, given P equal to 6 Newton, theta equal to 30 degree, W same load, W equal to 30 Newton, mu equal to 0, smooth inclined plane. The inclination of the plane is such that a force of 6 Newton inclined at 30 degree to a similar smooth inclined plane. Theta is 30, this is theta. Mu equal to 0 as smooth inclined plane. Alpha we find out. Okay. Alpha is same for smooth inclined plane and rough inclined plane. Okay. From case 2, when the plane is smooth, we find out alpha. Here this is smooth inclined plane, mu equal to 0. Smooth inclined plane, mu equal to 0. Let inclined plane angle with horizontal alpha. Weight of the body act downward, W. R normal reaction perpendicular to the inclined plane, P applied force 6 Newton, P theta degree with inclined plane, theta equal to 30 degree. We project this line. Component of W in this direction, W cos alpha. Component of W in this direction, W. P force applied with theta degree. Component in this direction, P cos theta. Component in this direction, P sin theta. This is smooth inclined plane. So in opposite direction there is no frictional force. There is only force W sin alpha. Now considering equilibrium, since sum of the horizontal force 0, here we consider this plane. This is horizontal, this is perpendicular. Summation of H 0, summation of V 0, summation of X component 0, summation of Y component 0. Since sum of the horizontal force 0, in left side direction only force W sin alpha, in right side direction only force P cos theta. Value of W 30 sin alpha equal to value of P 6 cos 30 degree, value of theta 30 degree. From this we find out alpha equal to 9 degree 58 minute. Okay, alpha find out. Now we solve the main problem. This is rough inclined plane. Incline alpha degree with horizontal. We just find out value of alpha. P force applied in parallel to the inclined plane. Frictional force act in this direction, F equal to mu r. R is the normal reaction perpendicular to the inclined plane. W always act downward. We project this line. This is also alpha. This is alpha. This is also alpha. Component of W in this direction, W cos alpha. Component of W in this direction, W sin alpha. Now considering equilibrium, since sum of the vertical force equal to 0, we consider this plane sum of the vertical force, upward force R, downward force W cos alpha equal to W equal to 30 Newton cos 9 degree 58 minute equal to 29.55 Newton. Now again, since sum of the horizontal force 0, in left side direction horizontal force we consider this plane, this inclined plane. In left side mu r plus component of w, w sine alpha. In right side direction only p. So sum of the horizontal force 0, p equal to mu r, this is mu r, plus component of w in this direction, w sine alpha, equal to mu equal to 0.3, r equal to 29.55, plus w equal to 30, sine alpha equal to 9 degree 58 minute. Value of alpha we find out from previous case. So P equal to 14.06 Newton. This is the answer. Clear, my student? Okay, thanks.